Hello class, today we're going to look at lesson 3 of the aqueous solution unit, and this is about the stoichiometry of neutralization. So first thing first, let's define what is neutralization. So simply, the definition is when you have an acid, second here, combined with a base, what you get is water plus salt, depending on the elements that are combining. So that is always what you're gonna get when you have neutralization. So we know that at the point of neutralization, the amount of the hydride ion is equal to the concentration of the hydroxide ion. And this is hydride. Hydride can also be seen as H3O plus, and this is the hydronium. So hydride concentration is equal to the hydroxide concentration. That is at neutralization. The number of moles of the hydride ion from the acid is equal to the number of moles of the hydroxide from the base of that solution. So if we were mixing solutions of known concentration, the number of moles is of hydride or hydroxide is equal to the concentration of the hydride multiplied by the volume of the acid. And same thing with the number of moles of hydroxide in a base. This is an acid and this is the base. You will have the hydroxide concentration times the volume of the base. So the steps for solving neutralization reactions. Step 1, write the balanced neutralization equation. Step 2, you're going to substitute the given values into the equation above and solve for the required amount or find the moles of a given amount. And then we have to use the stoichiometry to find the moles. So this stoichiometry means you have to have the balanced chemical equation for the acids and bases involved. So let's take a look at an example here. So calculate the concentration of hydrochloric acid. If 25 ml is just neutralized by 40 ml of a 0.15 moles per liter sodium hydroxide concentration. Recall that the concentration molars, molarity, is the same as the number of moles per liter of solution. So because this is given in milliliters, we need to convert this into liters first. So you'll have to divide this milliliters, and there are 1,000 milliliters per liter. So this will be, you're gonna move it 3 times to the left, 1, 2, 3, 0.025 liters of solution for the volume of hydrochloric acid. What else do we know? This is neutralized by 40 mils. So again, this is now for the sodium hydroxide volume. This is 40 mils, so 40 divided by 1,000, so 0.040 liters. You have to move it 4 times over to the left. And so now we have the volume of the acid and the base. And we can now use the equation to solve for the concentration of hydrochloric acid in this equation. So first thing first, we need to write the step 1 is the balanced chemical equation for the neutralization reaction. So we have hydrochloric acid HCl plus sodium hydroxide, and this will result in the Na and the Cl combining. So you have your salt and water. So these are all aqueous, and this is soluble aqueous, and this is liquid water. So let's take a look at the stoichiometry. 1 sodium, both left and right. For chlorine, you have 1 and 1. For water, you have 2 hydrogen here, 2 hydrogen. This is already a balanced chemical equation. So that's step 1. Step 2, we are going to use the formula we're looking for the concentration of the hydride, so H. So we can say that CH is the concentration of the hydroxide times the volume of the base. And this is, by the way, divided by the volume of the hydride. I'm going to just write the general equation here. So it is really the concentration of the hydride times the volume of the, this is volume of the acid, is equal to the concentration of the hydroxide times the volume of the base. So we're looking at the base as the compound and not just the hydride or the hydroxide versus the concentration of the base. So from that equation, we manipulated the equation and we got this. So now we fill in the unknown. So to find the concentration of the hydride, the concentration of the sodium hydroxide is 0.15. This is moles per liter. And the volume of the base, sodium hydroxide, is 0.040 liter. And as you can see, your equation is correct because the liters will cancel. And so the concentration of the hydride, just get the calculator here, is 0.240 moles per liter or molars. So that's our example 1. Now let's take a look at example 2 here. What volume of 1 moles per liter potassium hydroxide is needed to neutralize nitric acid? So we have potassium hydroxide. Let's start with the stoichiometry. The equation here is KOH for potassium hydroxide. And you're adding that with nitric acid, which is HNO3, both aqueous. And this will result in always water, liquid, plus the salt that you combine is potassium nitrate, so KNO3, aqueous. Nitrates are soluble. So looking at the stoichiometry, potassium 1:1, nitrate 1:1. So you can actually look at the whole polyatomic ion here of nitrate. And your hydrogen here, you have 2 on the left, 2 on the right, and oxygen, you have 1 here and 1 here. So this is already a balanced chemical equation. So we've taken care of the stoichiometry. So we're looking for the volume this time of potassium hydroxide. So the formula is the concentration of the hydride, volume of the base is equal to concentration of hydroxide, volume of the base. And this is actually volume of the acid. Just got, let's see here, is this working? Okay, looks like I have run out of this. So this is acids and acids combined. Okay, so we're looking for the volume of the base. So this one here, so volume of the base is equal to concentration of hydride, volume of the acid divided by the concentration of the hydroxide. Okay, so putting the numbers in, concentration of the hydride here, nitric acid, 0.500 moles per liter, times the volume of the acid, which is 750 divided by 1,000, so 0.75 liters. Okay, divide that by the concentration of the hydroxide, which is 1 1 moles per liter of potassium hydroxide. So we are going to end up with liters. So the moles will cancel, and we are looking for the volume of the base. And when you, because these are all 1-to-1, we went ahead and went straight for the equation. So this is a so far a simple calculation. So the volume of the, what do we have here? The volume of potassium hydroxide is, okay, just grab my calculator here. Okay, here we go. 0.5 times 0.75 is 0.375 liters of potassium hydroxide. Okay, so far we've only dealt with monohydroxic and monoprotic, and we haven't really looked at the stoichiometry in terms of ratio. Now, neutralization with polyhydroxic bases and polyprotic acids. Now, in our previous lesson, we defined poly. Poly is a multiple, hydroxic is OH negative. So polyhydroxic bases are bases that release more than one hydroxide in solution when it dissociates in water. So more than one. Whereas the polyprotic acids are acids that release more than one hydride. Okay, so those are the simple definitions of polyhydroxic and polyprotic acids. In this example, we have magnesium hydroxide. So I'm just going to write down again magnesium hydroxide, and I'm going to start from the ion. So from your periodic table, you'll know that magnesium is a +2, hydroxide is a -1. So when you combine these two, you will see that you will have 2 hydroxide in this compound. And this is being added to hydrochloric acid, and we have written hydrochloric acid a few times, so you have HCl, and this is a polyprotic or dihydroxic. This is the base, so di for 2, and this is a monoprotic acid. Okay, so let's take a look at the neutralization equation. So now we're going to combine MgOH2 aqueous, that's magnesium hydroxide. Combine that with hydrochloric acid, and you're going to get your water, liquid form, plus magnesium chloride. So this will be MgCl. Because you have magnesium is a +2, you will get MgCl2. Okay, so the ratio is 1-to-2. So we are looking for balancing this as well. You got 2 magnesium is 1-to-1. Hydrogen here, you have a total of 2, and 1 is 3. So this one only has 2. So just quickly balancing this now, we'll have to put 2 in front of HCl and 2 in front of water. So if you double check that, everything is going to be balanced in both the reactant and the product side. So what are we looking for here? You have 0.225 of the base. So I'm just going to write down what we know. So the volume of the base is 0.225 liters, and this is neutralized by the volume of the acid is 0.125 liters. Concentration of the hydrochloric acid here is 0.2 moles per liter. We are looking for the concentration of the hydroxide, which is the magnesium hydroxide. So to find the concentration of the magnesium hydroxide, I'm going to show you the work here. So magnesium hydroxide, so we have, what's given here is, so the concentration of the base is equal to the concentration of the acid, which is this one here, point hydroxide. What do we have as the concentration of the hydroxide here? What is the, we need to find the concentration of the hydroxide first, because we're looking, the actual question is the concentration of magnesium hydroxide. So we need to do a little bit of work before we get there. So concentration of the hydroxide is equal to the concentration of the acid, hydride, times the volume of the acid divided by the volume of the base. Okay, so what's our concentration of the hydroxide? The hydride is 0.2 times the volume of the acid, which is 0.125, divided by the volume of the base is 0.225, and this is going to give you 0.2 times 0.125 divided by 0.225, and you get 0.111 moles per liter of hydroxide. Okay, so far we know the concentration of hydroxide. Now we need to find the concentration of the entire compound magnesium hydroxide. So looking at the stoichiometry, we know that 0.111 moles per liter of hydroxide, the ratio is magnesium is, there's 1 mgOH2 for every 2 hydroxide. Okay, so that's a ratio based on the stoichiometry of the balanced chemical equation here. So you can see 1 magnesium hydroxide, okay, will produce 2 hydroxide when you balance the chemical equation up here. Okay, so that's how I got the 2. And that will give you 0.111 divided by 2 is 0.0556 moles per liter of magnesium hydroxide. So that is the answer for this question. So magnesium hydroxide is 0.0556 moles per liter. It's the concentration. Okay. Example 4. Calculate the volume of 0.1 moles per liter carbonic acid needed to neutralize 25 mils of 0.2 moles per liter of sodium hydroxide. Okay, so carbonic acid is H2CO3. Again, so carbonate, so you have your H plus and you have your CO3. This is -2. Again, you can consult your the back of your periodic table for the polyatomic ions, and you'll be able to put them together. Okay, and this is sodium hydroxide, as we know, is NaOH. So we're looking for the volume. I'm just going to write down what are the known values and what's unknown. So the volume of carbonic acid is what we're looking for. So this is the volume of the acid. That is the question. And needed to neutralize sodium hydroxide. So we know the volume of the base is 25 divided by 1,000, so 0.025 liters. And sodium hydroxide, concentration of sodium hydroxide is concentration of the base is 0.2 moles per liter. Okay, so let's write down the equation here first. So H2CO3 aqueous plus sodium hydroxide forms water, liquid, and Na2CO3 aqueous. These are all aqueous. Okay, so balancing this, we need to put 2 in front of the sodium hydroxide and 2 in front of the water, and that will balance everything. So because we're looking for the concentration of the hydride, you'll see the ratio here is that for every, that this is a 2 hydride that's going to be the result of the carbonic acid when it dissociates in water. So this is a diprotic acid. So we'll have to look at the stoichiometry. So the concentration of the acid here is double that of the H2CO3, because when you dissociate carbonic acid here in the beginning, as I shown you here, you will have to produce 2 hydride for every 1 carbonate ion. So this is a diprotic acid. So you'll have to double the concentration here, and this is going to be 2 times 0.1 moles per liter of this solution, and that's going to give you 0.2 moles per liter of the carbonic acid. The volume of the acid is what we're looking for. We know the concentration of the hydroxide is given to be 0.2 moles per liter, and the volume of the base, sodium hydroxide, is 0.025 liters, which is given as well. So now we can just put it in the equation. The volume of the acid is concentration of the hydroxide times the volume of the base divided by the concentration of the hydride. Okay, so we have 0.2 moles per liter times the volume of the base, which is 0.025 liters. You can see that will cancel, divided by the concentration of the hydride up here, which is 0.2 moles per liter. And as you can see, the moles will cancel, and you are going to be left with liters. So just calculating this, and you should have, so I can show you here. So 0.2 times 0.025 equals, divided by 0.2, and you get 0.025 liters of the carbonic acid. And this is what you need to neutralize the base. So this is how much carbonic acid you need to neutralize the sodium hydroxide in this solution of this given volume. Okay, now you can always pause the video and slow it down so you can make sense of these numbers, and hopefully you try it yourself. Now we're getting into the practice.